First, I'll be loading in all the resources that would be required for this project right here. Then we move on to part 1, data cleaning. As you can see, there's NAs here, which we do not want, where data is simply missing, or there's 2 day 3s here. We don't want to print it out always, we sometimes use this. It's preferable. Allows us to see there's one in each category where there's an NA except for days. And there's 3 duplicate days. We use this right here to drop all that data to make sure we don't have these NAs there anymore. This cleans the data. As you can see right here, there's no longer one in views, likes, comments, or watch time minutes, nor is there 3 duplicate files. Cleaning the data is important. It allows us to use the data without the worry of errors or polluted data that would mess with the modeling software, which we'll use soon. Next, in part 2, we need to explore the data. We need to know what type of data we're working with here. So we want the highest number of views, the lowest number of views, the average number of views, the highest number of likes, the highest watch time. If we look at the highest number of likes, it's much smaller than the lowest number of views. Based off of this, we can see this person is not getting enough likes per video. He might get a lot of views, but he's not getting much likes on anything. Data visualization. We need to see the data as well. It allows us to understand it more clearly. As you can see, this is a scatter chart, which shows us the trend it might take. But this sometimes is confusing, especially if there's too many dots. So what happens if we use a line chart? This line chart can clearly show the trends between each day a little more clearly than a dot chart can. Both are fine. But sometimes you want something else, so we use a horizontal bar chart. This allows me to see what individual days they got so many views, roughly. This is a good chart. Part 4, data modeling. Why is days the independent value and not views? It's rather simple. Days are not going to change randomly. It's going to be 1, 2, 3, 4, and so on. To be dependent on something like views is going to go up and down, so it's dependent on days to make it more consistent. Otherwise, we could say, oh, on day 4, we were right here. It's so we can more easily see the data. Also, so the model can see the data as well, so it can see the trends it might take. Part 5, prediction and evaluation. Based off the data it's working off of, it thinks it has a score of 99%, which is really good. It predicts on day 40, they'll have this as a score. Of course, without all these dots. Decimal points, sorry. And this on day 45. And this on day 50. As we can see from this graph, it does deserve its 99% accuracy. But what if, in the future, it doesn't? The red line is to represent the predicted outcome. Part 6, future data testing. Although it stated it was really accurate, as you can see, it's no longer true. It has a 84% accuracy, which is not 99, but it's still really good accuracy. To get its true score, I used this, which tells me it has a 94% accuracy. The model's performance was rather good. I believe so, at least, comparatively. If you look at this data, over the 10 days it appears to be here, the data does seem to be a little more crazy after day 36. The data seems to jump up a little more, which can mean it's an outlier, which is fine. But it still has an 84% accuracy, which is really good.